Let's see this question. We have cubic root of 72 plus 32 radical 5. So if we can make the inside 72 plus 32 radical 5 to be a cube, then the cube and the index 3 will cancel each other. So that's our goal. Remember perfect cube. We have a plus b raised by 3. That's a raised by 3 plus 3a squared b plus 3ab squared plus b cubed. Remember, basically, this is one example of binomial theorem. Binomial theorem means I have a binomial, right? Two term. Binomial means two term. A is one term, B is one term. So now when I raise by certain power, the first term goes, the power goes descending order. You see, you have a cube first term, a squared second term, a to the first power, right? Then no more a in the last one. The second term goes ascending order, right? You see in the first term, no b, that's b to the 0 power. Now b raised by first one, b raised by first power, b squared, then b cubed. And then where does the coefficient come from? You know, a cube has a coefficient 1, a squared b has a coefficient of 3, then ab squared has a coefficient of 3, then b cubed has a coefficient of 1. One way we could build this by something called a Pascal's triangle, right? Keep making ones. But for now, because we're only raised by 3, let's just remember this. The coefficient is 1, 3, 3, 1, right? So inside, so now we want b to be square root of 5. Why? Because in the question, we see square root of 5 is in here. So we said let it be, the second term would be square root of 5. In this case, we can substitute those b's, right? So 3a squared b becomes 3 radical 5a squared now. And 3ab squared becomes 3a radical 5 squared, which is 5. 3 times 5 give us 15. Then radical 5 to the cube, which is 5 radical 5. Then why do we do this? We want to compare with the given one. The given one is 72. So under the cubic root sign, we have 72 plus 32 radical 5. So we write those two equal to each other. Right? A cubed plus 3 radical 5a squared plus 15a plus 5 radical 5 equals to 72 plus 32 radical 5. Okay, now we put the like terms together. So a3 is a real number, is a rational number. 15a is a rational number. So we put those two together. So a cubed plus 15a has to be equal to 72. Because they are rational numbers. Right? So get first equation, a cubed plus 15a equals 72. Well, then we look at the like terms with the square root of 5. We have 3 radical 5 a squared, or 5 radical 5. And those two adds up to be 32 radical 5. Because we have equation, the left-hand side, right-hand side have to be equal to each other. So now we simplify this. Right? We can simplify radical 5. We can divide by radical 5. Oh, let's subtract. Let's subtract the 5 radical 5 from both sides. So 32 radical 5, subtract 5 radical 5, get a 27 radical 5. We just subtract the rational numbers, 32 minus 5, which will get 27. Then the like term, square root of 5, we keep it. Now we have 3 radical 5a squared equals 27 radical 5. Well, we can divide both sides by, 3 radical 5. Right? When we divide 27 radical 5 by 3 radical 5, we get a 9. So get a squared equals 9. That means a equals plus minus 3. Right? A equals plus minus 3. Well, now let's put it back in. A equals 3 and a equals negative 3. If a equals positive 3, so 3 cubed is 27, and 15 times is 3, which is 45. Add together is 72. Yes, so a equals 3 is a solution. What about minus 3? Minus 3 is not a solution. Let's see why. You see, if it's negative, a cubed is negative, and 15a is negative. It won't be a negative number, won't be equal to 72. So we just ignore negative 3. So we only have one solution. The solution is 3. So let's go back here. so, oh, hold on a second. So A, so we have A equals 3. So I have 3 plus radical 5 cube. So this one equals to 3 plus, let me write. So the solution for this, 3 plus radical 5 raised by 3, but we have this cubic root. Right? Remember, for rational exponents, we can write this as power is a numerator, index is a denominator. 3 divided by 3 that equals 1. Well, 3 plus radical 5 raised by 1. So that's just 3 plus radical 5. Okay, so that's the simplified version of this. I hope this makes sense.